Okay, so thank you to join this session, and we are going to start today's session on why numerical methods are essential for ordinary differential equations and what are the use and how during the entire session. Yeah, so there are two methods to find out the solutions of any kind of differential equations, but we are talking now ODE, ordinary differential equations. One is analytical solution and other is numerical solutions. So there are two type of difference. First, when we solve any differential equation or ordinary differential equation by using analytical approach. So this will provide us a solution which is in the form of closed form expression for the solution to the ODE. And these solutions often involve algebraic operations, elementary functions, and constants. Analytical solutions give an exact and precise representation of the solution of any point in the domain. They provide insight into the behavior of the system and may reveal general patterns. Analytical solutions are not always possible for complex or non-linear ordinary differential equations. In many cases, finding an analytical solution may be difficult or even impossible. Analytical solutions are more common for simple linear ODE. But in the case of numerical method and the numerical approach, numerical solutions involve using numerical method to approximate the solution to discrete points in the domain. And common numerical methods which are very familiar like Euler's method, Rankata method is there, and finite difference, which are highly useful for different type of computing. And numerical solutions are often more practical for solving a different type of solving a complex ODE and a system of equations, especially when analytical solutions are not readily available. They can handle non-linear and complex geometries. Also, the numerical solutions are inherently approximations, and the accuracy depends on the chosen numerical method and the size of the discretization of the steps. And smaller steps generally lead to more accurate results but may increase computation cost in the form of time and complexity. And these numerical methods are versatile and can be applied to a wide range of ODE, including those that may not have analytical solutions. So in summary, if we can say analytical solutions provide exact expression for ODE solutions when they can be found offering insights into mathematical properties of the system. Numerical solutions, on the other hand, provide a practical approximation for a broader range of ODE, making them applicable to real world and where analytical solutions are challenging or impossible to obtain. The choices between analytical and numerical methods often depends on the complexity of ODE and specific requirement of the problem at hand. So now the thing is why the complexity in ODE, many real world phenomena, just like described by differential equations that cannot be solved analytically. Numerical methods provide techniques to approximate solutions to these equations, allowing us to understand and model various physical, biological, and engineering system. Along with we have numerical methods for ODE can be applied to wide range of the problem across different disciplines, including physics, chemistry, biology, economics, and engineering. They offer a versatile toolset for tackling diverse problems involving continuous range. While analytical solutions may not always be possible or practical to obtain, numerical methods allows for different efficient computation of approximate solutions. With advanced in computing technology, numerical methods have become increasingly powerful and accessible tool for different type of problems. Along with we can by using the numerical approach, we can have ODE enabled the simulation and prediction of complex system behavior over time. And this capability is crucial for making informed decision, optimizing design, and understanding the dynamic of various processes during lockdown COVID time. We can see that there are several models has been established by using numerical approach, and all these predictions we can see in the real time. Okay, but in the case of if you want to use analytical approach, we are not able to optimize, and we cannot predict in real time. Okay, so by using numerical approach, we can easily implement for different type of prompts. Then after we have numerical methods provide framework for analyzing and controlling errors introducing during the approximation process, understanding errors, source, and mitigating their effects on essentials for ensuring the accuracy and reliability of numerical simulations. Also, numerical methods provide uh, practical approach for students and researchers to engage with differential equations without requiring advanced numerical expertise. They offer a bridge between the theoretical concept and the practical application, making complex problems more accessible and manageable. And we can have some real world application. Numerical methods are used to model the dynamic of mechanical system like pendulum oscillating spring, and vehicle suspensions. These simulations aid in designing and optimizing mechanical structure and predicting their behavior under various conditions. ODE are also employed to study the growth and interaction of populations in ecology. Models like logistic equations, Locta-Volterra equations describe predictor-prey relationship and species competition and population dynamic, allowing ecologists to understand and manage ecosystem. And also we can use ODE to the model behavior of electrical circuit, including transient and steady state responses. Numerical methods help analyze circuit behavior under different input conditions, design filter, and optimize circuit performance. And there are some applications in chemical kinetic, fluid dynamic, control system. ODE describe the rates of chemical reactions and species concentration over time. Numerical methods are employed to solve these equations, enabling chemists to study reactions, mechanism, design reactors, and optimize reactions conditions in a chemical process. And on the other hand, ODE are used to based on, and there are some models based on ODE, such as Navier-Stokes equations describe fluid flow phenomena in various engineering applications, including aerodynamic, hydrodynamics, and weather forecasting. Numerical methods are essential for simulating fluid behavior in complex geometric and turbulent flow regimes. And also we can use ODE model to model and analyze dynamic system and control engineering, including feedback control system, robotic system, and aerospace guidance system. Numerical methods aid in designing controllers, simulating system, and optimizing control strategies for desired performance. And we can have some examples in epidemiology, climate modeling, biomedical system. ODE play a crucial role in modeling the spread of infectious disease and predicting disease dynamic in population. Epidemiologists use numerical method to simulate disease outbreak, evaluate intervention strategies, and assess public health policies to control epidemics. And also we can use ODA for climate models simulation, the Earth's climate system, including atmospheric dynamic, ocean circulation, and interaction with the land and ice. Numerical methods help researchers understand climate variability, predict futures climate, and assess the impact of human activities on the environment. And these are also employed in biomedical engineering to study physiological process, drug kinetic, and disease progression. Numerical methods enable researchers to simulate biological systems, design medical devices, and optimize treatment protocols for improved patients' outcome. So there are various type of applications, and you can see in the financial modeling, and each applications demonstrate the versatility and importance of numerical. So this is all about why numerical methods are important, where you can apply, and why the difference between analytical approach and numerical approach. So most of the models which we can see in the real time, and these days all the development are based on by using this type of models. And I hope that when you will start to work on it, this will help you in different type of domain. Also, I will upload all this content which I discuss with you, and some PDF files all about the applications of this numerical method in all domain. Okay, these will be available along with this presentation. There are some PDF content. All these will be uploaded now. It is time to start today's session. Okay, so this is my MATLAB window. What we are going to cover today? The first method which we want to cover, Euler method, and this is simplest. But this method will help you in the coming sessions, because when you will deal this method for computing using MATLAB, this will help you to understand the syntax, how you can create the program. And in this method, what I am doing, I will discuss this method in three different way. Okay, how you can write one program, and then using the same program you can solve different type of equations. Just you need to write one time a program. Okay, so before starting, there are some participants who I think not familiar with these methods. Some may be new, but just I would like to overview about the method, and then we will start. Okay, so here you can see. So if we have dy upon dx is equal to some function f x y. Okay, so we are going to discuss very first method, which is Euler method. And if we have dy upon dx is equal to fxy, and this is the initial condition. Okay, so this condition is we are given to find out the solution of this differential equation, and how we can do. So the meaning of this initial condition we have is when x naught x is equal to x naught. When we have x is equal to x naught, then we have y is equal to y naught. So this is the initial condition. This is some function. Dy upon dx is the slope of some function. But if you have this curve, and at this point we have, suppose this is the initial point P, x naught and y naught. Okay, and we have horizontal and vertical lines. This is the origin, and at this place we have x-axis, then we have y-axis. So here we have, this is, suppose that this is the point P1, and from this point to this point, you can choose, this is x naught. Okay, so the coordinate of this one is x naught and y naught, and suppose that this is the final point. Here is a Pn, which is the final point xn. So we want to compute all the values from x naught to xn. Okay, so what we will do, we will divide this interval from x naught to xn in very small step size, say h. So the step size as much will be small, the values which we want to compute will be more accurate, and we will discuss, we will show after writing the program. So just first we need the method, what about Euler and how you can establish, then after we will do step by step. Okay, so at this place, when you will take slope, this is the slope. Okay, then when and you can see at this place, suppose that I have this is P2 and this is H. So at this place, what will be? This is X naught plus H. Okay, and at this place, you will draw a horizontal line. This will be horizontal line. And at this place, we have some angle theta. This is theta. So at this place, from this point to this point, suppose this is Q1. This is Q1. And at this place, we have Q. Okay. So this is Y naught. Then from this place to P2 dash, we have Y naught. Okay, and at this place we have a triangle. Triangle we have this triangle in this way. This point is P. Here is this point is P2. At this place P2, and at the curve we have Q1. Okay, and this point we have is theta. So if this value is H, what about QP2? So QP2 upon H will be equal to tangent theta, and QP2 will be is equal to H tangent theta. Okay, so this is the value of QP2. Now value from P2 to Q1. Value from P to Q1. Okay, this is Q1. So the value from P to Q1 is equal to, we have Y naught plus P to Q1. Okay, but value of Q1 P2 is H tangent theta, Y naught plus H tangent theta. And what about this one? This is Y1. At this point, we have the coordinate X1 and Y1. Okay, so Y1 will be equal to this value, and X1 will be equal to X naught plus H. What about now tangent? dy upon dx. dy upon dx is equal to tangent theta. Okay, so we will put, and also dy upon dx is equal to fxy. From this equation, we have dy upon dx is equal to fxy. So that's why tangent theta is equal to, I will use directly f, x and y. But this value is at the point P, and the value at P, the coordinate are x naught and y naught. So that's why tangent theta will be is equal to f, x naught and y naught. Okay, so we will put this value at this place. Now y1 is equal to y naught plus h, f, x naught and y naught. We have this one. So we start from this place, x is equal to x naught and y is equal to y naught. And then we have x1 will be equal to x naught plus h, x naught plus h, and y1 will be equal to y naught plus h, f, x naught, y naught. Similarly, when you will do for the next level, okay, you will have x2 is equal to x naught plus 2h, and y2 will be equal to, and for this point, this will be the initial point, initial values. Okay, so that's why this will be equal to y1 plus h, f, x1 and y1. And at the place of x1, you can write y1 plus h, f, x naught plus h and y1. Okay, so this is y2. Now you can generalize in this way, and its generalized form will be yn is equal to, this is the generalized form, yn is equal to yn minus 1 plus h, f. At this place we will have xn minus 1 and yn minus 1. So this is the Euler method. Okay, now by using this method, we want to write a program, and then after we will calculate all the values. Okay, but you have to remember this formula. Okay, so these are the steps. Now come in the MATLAB. So you can see this is my MATLAB window, and first I want to open this file and this file. Okay. So in this method, what I have done, I chose very simple example, and after understanding this uh, computing part, you will be able to use for different type of prompts for different initial conditions. Okay, and once you will understand this very first example, then we have another two ways to write the program. And I am sure this will help you in many ways. But the most important thing is that you need to understand the meaning of every line. This is the most important. Okay, every statement is important. So what I have done at the place, we want to implement the Euler's method to compute for this dy upon dx is equal to fxy. I have the example dy upon dx is equal to x square plus y. Okay, and this is the initial condition, y naught is equal to 1, y0 is equal to 1. So first we will define all the initial conditions and in which interval we want to use. Yeah, and at this place the final value xn is at this place final value. Xn is equal to, we have 2. You can choose 1 or 2 depend upon our choice. So the initial condition, when x naught is equal to 0, y naught is 1. So this is the initial condition. Okay, so initial value of x, and I comment every statement so that this will help you after listening the lecture and while you want to use. Okay, every statement I have expand with the comment. And this is the final value. So we have the interval for x 0 to 2. The meaning of this one is we have the interval from this is the, sorry, okay. So this is the initial value and this is the final value. So we have the interval 0 to 2. For this interval, we want to compute. And after we need also the step size, depend upon our problem, and to make more accurate, we need small size. Okay, later on we can change, but here we I choose n is equal to 10, and later we will make more step. Okay, when we have more number of a step in the interval, the step size will be small. Okay, so this is the formula. H will be is equal to x naught minus xn minus x naught upon n. So by using this one, we can get the value of h. After that, we have is, yes. After getting the step size, you can see here is x zeros. Okay, zeros means zero vector. Okay, zero matrix, zero array. But here we have X array. Okay, we generate first initialize arrays to store the values of X and Y, which we will compute for the numerical part. Okay, so what is N? N is a number of a step, and similarly we will compute Y. If you want to check the sense of these values, you can check. So that everything must be very clear, and in the coming I will not pay more attention about this, but this is the first program, so I have to expand everything. See, I want to minimize first and then check here. This is the x naught, okay, and you can copy and paste here. So this is the initial value, then we have y naught, this is the value of y, no problem. Then we have the value of xn, then you need to compute the value of h. We compute in the command window. Now xn, okay, the value of n not assigned. Yeah, n is equal to, you can give at this place 10. This is the value of 10. Now we can compute h. Yeah, see, What is the purpose of this one? I will copy from and paste in the command window, and you can see the result. This will generate X array. This is the X array you can see in the workspace. If you want to check the values corresponding to this statement, this will only have 0 elements. You can double click and check here. You can see all the values are 0. Okay. So this will generate only the arrays, and corresponding to all these we will compute, and these will automatically updated in the same length, because we need the same length of X array and as well as Y array. Okay, X is independent and Y is dependent. So both have the same length, as well as all the elements will be 0. Now, this is one part. Now come here. Now we will apply the initial conditions. X1. What is 1 at this place? 1 is index. 1 at this place is index. Okay. And X1 is equal to X naught. And Y1 is equal to Y naught. These index are used for only the initial conditions which you are given at this place. Okay, so this is X naught, this is Y naught. These are given to us, and on the basis of this value, we will update all the values corresponding to the index, and we will get all the values of this X array and Y array. See, so now this is the initialization of index. X1 is X naught and Y1 is Y naught. And the corresponding values of X naught and Y naught we have already defined in the above statement. Now this is the main part to implement Euler method. Okay, this is the main part. Only this part is very important for you, and once you will able to understand, everything will be very fine. Okay, so here is what was our method when we have x1. When we have x1, this will be equal to x naught plus h, and y1 was equal to y naught plus h f x naught y naught. Okay, see this program. First, what will be I is equal to 1 to n. Okay, I is equal to 1 to n, but the value of n is 10. So this will start from 1 to 10. So when it will take I is equal to 1, this will be x1 plus h. Okay, and at this place 1 plus 1 2, this is x2, like in this way. Okay, so in this is the first index. First index is x1, and x1 is x naught. Okay, so this is the value of x1. And what is x2? X2 is the updated value for the this is the x0, and at this place we have the next value x1. Okay, so this is x1, which will be we get by using in this way. And at the same place, when we have I is equal to 1, C at this place. Okay, here is y1. Here is y1. This is y1. Y1 is first index, but first index is this one. See carefully. Y1 is first index, this one. Okay, this is y1 plus h. We have the step size, and this will pass at this place automatically. Now we have f x naught y naught. So at the place of f, I have my ODE, and at the place x naught and y naught, you will see this will be x1 and other will be y1. Okay, and this is f. So this is for about I is equal to 1. Okay, both are computed at this place, but there is one problem. What about my ODE? Here is f is function. F is function. Okay, so my OD is function which is based on the given our problem dy upon dx is equal to fxy. So this I create a function in by a user defined function, and I save this function with the name of my ODE. Okay, and then I call at the place. Now I want to remove this part first, and then I show you. Yes. See at this place. This is our function. User-defined function we discussed in the previous lectures. How you can create user-defined function, and at this place I create user-defined function, and you can see the file name is this is the file name my ODE, and there are two arguments for this function x and y. Okay, and dy upon dx I have is x square plus y. Come back in the given statement. See, this is dy upon dx is equal to x square plus y. So we create a function at this place. Okay, so this function saved with the name of this file, and we are using at this place. Yes. So now I think it is clear to all of you what is the meaning of this one and how this loop will work. When we have I is equal to 1, we have x2 is equal to x1 plus h, and y2 will be equal to y1 plus h, and my OD I will write at this place f x1 and y1. Okay, what are x1 and y1? These are x naught and y naught. Okay, so for I equal to 1, all these values will be calculated and will store at this place. Again, we have the value of x2 and y2. When you will have I is equal to 2, at this place we have x2, at this place we have y2, and these values which are stored in the left hand side will automatically pass through at this place, at this place, and at this place. So this loop will repeat this task up to when we have n is equal to 10. Okay, and all values will be computed at this place. N are the number of steps. So 10 steps are there, but we have 11 values. We have 11 values. You can check in the just 1 minute, just 1 minute. Yes, you can check here. See this x vector. The size is 1 by 11. So if we have 10 steps, we have 11 points. I think you got about this loop, how this will work and how you will assign the values. If till now you have any doubt, you can discuss with me. Yes, please. Over to you. If you have any doubt related to this sequence of statement, you can discuss with me. I try to explain every step, but still, if you have any question, please feel free to ask from me. This is complete program for this Euler method. And here we create dy upon dx a user defined function, and we are we are calling the function at this place. This is dy upon dx. This is f function fxy. Okay. And as we establish the formula in the same way, we are using at this place. But only the thing is, all the above statement are same. This is a little bit new for all of you. Okay, and but zeros vector I already explained in the previous lectures. For loop I already explained how you can use. I provide you 10 examples for different use, and you can see the same use at this place. If still you have any question, please feel free to ask. Otherwise, and then after you need numerical result, you want to show the graphical, you can easily pass these values, float, xy, this is the x label, y label, title is also there, grid on. Okay, so when you will execute this file by pressing at this place, and you can see you can see you have a wonderful graph. Okay, you can see very wonderful graph at this place. Okay, but now we can do one more thing. We can do one more thing. You can do one more thing. You can use at this place close also. Okay, clear and close. Why we use close? And at the place you can take 50. Okay, and see. So as much the step size will be small or number of points will be more, the result will be more accurate. If you will choose at the place only 5, see, this look like in this way. Okay, but if you will increase the number of steps, this will be more accurate. Okay, once you will write the program, after that you can do numerous experiments. You can choose at this place 100. Okay, then run the program, see the result. Okay, so as much you have the number of steps are more, you have more accurate solution, numerical results, and you can do several experiments by using the same program. And according to your desired value, you can get all type of desired results what you have. Now, what you will do for different type of examples, just what you do, you write, you need to modify only at this place. Okay, suppose I have the differential equation dy upon dx is equal to x square plus at this place I have a sine function, sine x and product. Okay, and save it. But we have the initial conditions are same. You can, if you want to change the conditions, you can do. Okay, and when you will execute, you will have different type of result. You have different result. Okay, if you can make at this place minus, you can take at this place minus. Okay, and save it. So if you are updating something at this place, you need to update the values. You need to save the file first, and then after you can execute and see the graph. Now you can see this is another graph. Okay, so you can, after writing the program, you can manipulate for different type of examples which are related to dy upon dx is equal to fxy. Okay, you can choose your own examples. So this is the simplest way to discuss and to write the program, and then after you can do several experiments. Fakri Yaya raised the hand. Yes, please. Yes, please. You can unmute your mic. You can unmute your
Hello,
mic.
sir.
Yeah, hello.
Hello, yeah. Okay, if I want to do more than one graph by using the same method, how I can do it?
Yes. You can draw more graphs, but the thing is that did you attend my older lectures? Did you attend all the sessions?
Yeah, I attend, yeah, most of them, not all, but most of them, yeah. I mean, specifically in this method, can I do more than one graph together?
Yes.
This is my
You can plot more graphs in the same. But my question is, I there was one special session on the 2D and 3D plotting. Okay, so by using the same syntax, you can do multiple graphs. But here we have the one example, one problem. Okay, if you want to insert some more, you can do for different problems, and these will happen in the coming sessions. Don't worry. If you
Okay,
want
sir.
to,
Okay.
if you want to include or you want to do on this example, you can do. But first, you need to go through the my old lectures in which I discuss about 2D and 3D plotting, then multiple graphs in the same image. Okay, there are several ways. But if all the concepts are clear, then you can easily implement at a place. First, you must try yourself, and if you have problem, you can share with me.
Okay,
Okay,
sir. Okay, sir.
no issue at all.
Okay.
Yes, I think everything is clear. So the program which we write, we discuss every statement, every step, and workflow of the program. If still there is any doubt, any question, please feel free to ask. Otherwise, there are two more ways we will discuss here. Okay, thank you. So once again, I'm going to share my screen, and yes, so this is my metal window. I want to close these files and come to numerical method. This is the second example. Okay, so in this method, what I have done, I have create function for Euler method. Okay, whatever we need for the Euler method, you can see I have write the same. Okay, so see, I need to clean and then come here. Yes, so for the Euler method, these are the initial conditions, this is the step size, and this is the maximum value. Okay, or x maximum or the final value. So if you have interval a to b, the initial conditions are given, and this is the last value. This is x naught, and this is x maximum. Okay, and the step size which you will divide, this is h. So you need to compute all these values, and f is the function. What is f? F is equal to dy upon dx. Okay, so that is also argument at the place. Then, as you know, we need to generate y zeros, and here we will create x array from x0 to x maximum, and depends upon the value of h. Okay, so the length of this vector and y both are same, because the size of x will pass at this place. So that's why both are equal size. And then after we need to index the initial value, and you can see this is the y1, the first value, which is y naught. Okay, then after we need to apply loop for I is equal to, why we start from this, I is equal to 2 to length x. Length x means how many values are there in x vector. And index we start to at this place from 2. Why? Because first index is there. The value of I is equal to 1, then 2, and so on. So I is equal to 1 we have already at this place. So this will start from 2 to the last value of the index. And this is the same. You can see this is the same as we use in the first example. Okay, yi minus 1, then h, then at this place we have f function. This is the xi minus 1 and yi minus 1. When you will have I is equal to 2, this will be x1 and y1. Okay, and also at the place of my ODE, okay, we have f. So this is all about the Euler method. We create user-defined function for Euler. Okay, now come back how you will use C at the place. So this is f. We have to define. You can write f by using what is this type function in the MATLAB?
Anonymous function.
Yeah, this is anonymous function. Okay, we create at this place anonymous function. Then we have the initial value x naught is equal to 1, y naught is equal to 1. The value of h is 0.1. This is the final value x maximum. Then after call Euler method function, which we create here. Okay, what we will do, we will pass all this argument at this place through this method. But we have two values, one is x and one other is y. When you will solve the equation, you have one is independent and second is dependent, x and y. So we need to save both the values in two vectors, one is x and other is y. Okay, that's why we are using in this way. And come back, see this part. This part will be completely used at this place, so that we can save both the values. Okay, then after we are using at this place plot function, and rest all the things are same. You can see, and when you will execute, okay, where is the result? Just 1 minute, where is the result? Here is the result. You can see here is the result. So what was the problem here? Why this was not appear? We have to use at this place close. Okay, and then you can run. Yes, you can see. If you need more accurate, what you will do? If you need more accurate, what you will do? You will decrease the step size. You can use at its place 0, 2. The size is more small. Okay, far more accurate. Yeah, you can see. Here is the graph. Now you can easily make changes at this place. Just you need to play this code, this file only. You have create Euler method function. This is, you can see. And just you need to play this script file to get the numerical values. Okay. Is it easy? Is it easy? And if you want to display X and Y, then enter. So these are the numerical values of X and Y. You can do in another way. You can do in another way. You can write here x1 is equal to x transpose. X transpose. Suppress it, and y1 is equal to y transpose, and suppress it. Then you can have x1 space y1, and then enter. You can see all the values. The first array is of x, and corresponding to in the second array we have the values of y. You can check it. Okay, so whether you want to get the numerical value or you want to compute, you want to plot the graph, both the ways are there. And also the same you can include at this place. Okay, you can write in this way: x1 is equal to x transpose, and then suppress it. Y1 is equal to y transpose. Okay, and suppress it. Then you can write z is equal to we have x1 space y1, and then suppress it. So these two vectors will be stored in z. Okay, and then display z, and now execute this file. So you will have the graph as well as you will have the numerical values. See, all type of numerical values are there. Okay, you have graph as well as numerical values. So this is the second part of the same method in different way. There is one more example to write the same code for the Euler method, and this is the third example. You can get the third example. Yeah, this one. Okay, we have ODE1, and then we have okay and okay. Yes, you can see at this place we define only ODE1. dy upon dx is equal to x square minus 1. Okay, and then after these steps are similar to the first example. Okay, similar to the first example, you can say x naught is equal to 0, y naught is equal to 1, but we have the same example. Example is same. We did not change at the place. Okay, so you can say dy upon dx is equal to fxy and ODE1. Okay, then you can see at the place x range. X range we have is 0 to 1. Okay, we are, and h is the step size. Then after numerical points, we need to initialize. So this is the length, how much points are there, and because we need the zeros corresponding to y. So the length of x input and y both must be same length. Only then we can have the numerical values. Okay, so here is num point length of x. So depend upon these values. And then after zeros, so zeros 1 to num point. So this will start from 1 and goes to up to the length these number of points. Okay, so this y and x will have equal length, and this is the first index, first value of y function, initial value. So y naught, y1 is equal to y naught. Y naught is the first index for y. Okay. Now we want to use apply Euler method, and here you can see for I is equal to 1, 2, num point minus 1. Okay, num points. So how many points are there? We are getting from this place. Okay, so we have to choose that place minus 1, because a number of steps will be one less. Okay, that's why. And yi plus 1 is the same as we are using Euler method. This is y1 plus h ODE, this function which we created at place, and then we will pass the values x range, because this is the index. We are using this index, so all the values will pass through at the place, and I is the index. So this will, I will choose the first value, second value, third value, fourth value, and the last value from this place. Okay, and corresponding to the same, we have the all the values of yi. Okay, but initially this will start from this place, first index. We have to give the first index at this place for I is equal to 1. So all the values, when this will be updated, we will have the value of y2 for I equal to 1. We have all these values. Okay, and all these values after computing will store at this place. We have y2. So when we have index 2, this value will pass on the right hand side, and we will have the value y3, and so on. This loop will work as we discussed in the very first example, and same in the second example, same in the third example, but ways to write are different. Okay, and then we have the same process to plot the graph. When you will execute, you can see we have the same graph. At this place you need to use just 1 minute, we did not include at this place CLC, clear and close, and now execute. Yes, you can see we have the graph. Okay, you can decrease the step size 0, 1. Okay, now it will be more accurate. You can see. Okay, so in this way you can easily play with these codes, and you can make changes according to your desire. You can make at a place plus y. If you will choose at a place plus y, first you need to save, and then you need to run the code. Come here, and you can see the graph of the function. Okay, and here we have the different example. Example is same. Okay, just only we have the code, and you can follow. Yeah, there is one another example to write the code in different way. We are using while loop. We are using C at this place. We are using while loop. Okay, so this loop will work until we have the last value xf. Xf is the final value. What is xf? Xf is the final value. See here we have x naught, y naught, and this at this place we have 1. 1 is the final value, and what you will assign at this place depend upon the final value. Okay, so this is the final value, xf is equal to 1. So this step is same, this is also same. Okay, and then after we need to assign at this place x is equal to x naught and y is equal to y naught, and we are computing slope. What is this one? This is slope, dy upon dx. You can save in the name of slope. Okay, and this is the formula. This is the formula, y is equal to y plus h product slope. So by using while loop you can do in this way. So this while loop, this loop will work until we have the last value. So all the values will be computed automatically and stored in the y vector, and at the end you can see x is also increment to step size, both we required, and both will have equal length. Now x values and y values will be stored in these two argument, and after that you can use for the plot. You can use for the plot. So this is also the another way to write the code by using you can use either while loop or for loop. Okay, but in the use there is a little bit difference. So the most important thing is to use the loops, conditional statement, and how you can manage the sequence of statements. So this will take some time, and I three examples which I write for different type of programming for the same method has been discussed. If you have any doubt related to all these examples, you can yes, we can obtain the error also. Yes, we can obtain the error. Okay. So in the very first lecture, just we need to discuss only how you can compute, how you can write the program, and then how you can compute the numerical values and how you can plot the graph. And everything what is required for this method, we have discussed. Still, if you have any question, you can discuss either. Yes, please.
Sir,
Or to
sir, is there any standard method to solve the equation directly? Means solve type any method to solve the differential equation so that we can find error exact solution.
okay, exact solution. For the exact solution, we have analytical approach. There are many methods to get the solution of all type of differential equations, and we have studied in the lower classes. Okay.
No, sir. In MATLAB, is there any ready-made function to solve the differential equation?
Okay, okay. In MATLAB, yes, we have in the MATLAB to get the analytical solution. We have. Okay, I will provide you the if you will go to channel, there are some OD methods I have already displayed, and if you want to include, I will upload the how you can use analytical approach in MATLAB. We can do, but you know, as we discussed in the beginning, there are various type of complexities while we are using analytical approach, and all type of equations we don't have solution by using analytical approach. That's why numerical methods has been developed. Okay, so numerical approach reduce the complexity in all type of differential equations. But if you need example to use analytical approach, yes, we can use. Okay, but along with you must be familiar with the symbolic mathematics. Then you will be able to use analytical approach in MATLAB. Are you familiar with the?
Yes, sir. Yes, sir. I heard about it. We
Okay.
can work with symbols
Yes.
also.
Yes, yes. Just 1 minute. Just 1 minute. I am sharing my screen, and you will go to this lecture. You can find easily in Foundation YouTube channel. Okay, just 1 minute. I am show you, and in the detail we explain. Here you will enter Mathematic Thinking Foundation. You will enter Mathematic Thinking Foundation, and then you can easily find. Click on the logo, then go to the playlist. Okay, and in the playlist here are there was a tutorial series. Okay, so here you can find symbolic math toolbox. Then yeah, you can see lecture number 11. Okay, so here we explain how you can compute differential equations analytically. Okay, here you can get several approach, and a higher order also we introduce in this lecture. And here is the solve differential equations, algebraic equations. So, and here is also these three lectures are there. Stiff, non-stiff problems are also there. ODE initial problems. There are several lectures, and also we have solve differential equations using Fourier Laplace transform, and here are some numerical methods. Okay, so these 3 lectures are uploaded because this was the live series. Okay, so here you can get some examples for analytical solutions. Very helpful for you.
Okay, sir. Sir, can
Okay.
we get the link if possible, please?
Madam, this is very quite simple. Just you will search in the YouTube Math Tech
YouTube.
Thinking Foundation. Yeah,
Okay,
just
okay, sir.
you will go to the YouTube and find Math Tech Thinking Foundation.
Okay,
Okay,
sir.
and then when you will click on the logo, okay, all the lectures are there. You need to go to playlist. So all the playlist you can find easily at this page.
Okay, sir.
Okay, this is the playlist. MATLAB tutorial series 2023. Okay, when you will click on it, all the lectures in the sequence are there.
Okay, sir. Thank you,
Yeah,
sir.
there are 16 lectures and each lecture are more than 2 hours. Many things are there and very useful. Okay, any
Okay,
more
sir.
question, please? Any more question, please?